In this class, we are going to discuss about the effect of source inductance on a fully controlled rectifier with constant load current. Source has a some amount of inductance that we are showing here. It is a fully controlled converter, RLE load. In this case, we have taken the constant load current. So to see the effect of source inductance, we have taken the two cycles of the input voltage VAB, VBA with a dotted line, pi, 2 pi, 3 pi, 4 pi. We are applying the technical voltage to the T1, T2 at alpha and 2 pi plus alpha. T3, T4 we are applying the technical voltage at pi plus alpha and 3 pi plus alpha. Now we start developing the output voltage waveform from alpha. If we take the continuous operation of the circuit, at angle alpha we are applying the technical voltage T1, T2. So the load current will be transferred from T3, T4 to T1, T2. So the current through the T3, T4 will be slowly decreases and current through the T1, T2 will be slowly increases because of this inductance. Some duration all four devices are conducting. So the output voltage becomes a 0 for some duration. That duration is nothing but a overlap angle. So this is alpha. Some duration all four devices are conducting. Now after overlap angle T3, T4 will be off, T1, T2 will be on. Once the T1, T2 is on, load is connected to the source. So the load voltage same as the source voltage up to pi plus alpha. At pi plus alpha, we are applying the technical voltage to T3, T4. So the current through the T1, T2 will be slowly decreases. Current through the T3, T4 will be slowly increases. Some duration, again 4 devices are conducting. Again the output voltage becomes a 0 when the 4 devices are conducting. That angle is nothing but a overlap angle. See from this point to this point. At this point, T3, T4 is on. So the output voltage follows the input voltage, that is VBA. The same thing will be repeated for the remaining cycles also. Here we have taken the load current as a constant load current. This current is nothing but a IBA. At alpha, T1, T2 is on. So the current through the T3, T4 will be slowly decreases. Current through the T1, T2 will be slowly increases. This is IAB. Again at pi plus alpha, current through the T1, T2 will be slowly decreases. Current through the T3, T4 will be slowly increases. In this duration is nothing but a overlap angle. In the overlap angle, all four devices are conducting because of the source inductance. Same manner here also. Here also. Now we want to find out the average output voltage. To find the average output voltage, I have to find out the repeated waveform. Alpha plus mu to pi plus alpha. What is the waveform is there? The same waveform will be repeating. So the base length becomes a pi. So 1 by pi integral alpha plus mu to pi plus alpha Vm sin omega t d omega t. Vm is a constant, take outside. If we complete this integration, V naught equal to Vm by pi cos alpha plus cos of alpha plus mu. Mu is nothing but a overlap angle. This overlap angle is highly depending upon the amount of source inductance. Now we are going to keep the same circuit operation, the table form. Alpha plus mu 2 pi plus alpha, T1, T2 is conducting. The output voltage is VAB, nothing but this one. Again in this duration, pi plus alpha to pi plus alpha plus mu, all four devices are conducting. The output voltage becomes a 0. During the overlap angle, if you apply the KVL between the source T1, T2, T3, T4 means VAB minus LS into DIAB by dt equal to VBA minus LS into DIB by dt. VA nothing but a Vm sin omega t. VBA nothing but a minus Vm sin omega t. Substitute these two values, take one side. So finally you are getting the 2 Vm sin omega t equal to Ls into DIAB dt minus DIBA by dt. This you take it as the equation 1. We know that during the overlap angle, IAB plus IBA equal to I naught. Take the differentiation both sides. I naught is nothing but a constant load current. So the differentiation of the constant equal to 0. So DIAB by dt plus diba by dt equal to 0. Now you take this is equation 1 and equation 2. Solve these two equations. So finally you are getting the dib by dt equal to Vm by Ls into sine omega t. You cross multiply this one. diab equal to Vm by Ls into sine omega t dt. Take the limits. At omega t equal to alpha, current becomes I naught. So from these two, you find the time interval. So alpha by omega t. When omega t equal to alpha plus mu, the current becomes a 0. Nothing but current through the T3, T4 is coming to the 0. And T equal to, from this expression, you find the T equal to alpha plus mu by omega. Now you take the integration for this expression. Take the limits this side. 0 to I naught diab equal to integral alpha by mu, alpha plus mu by omega, Vm Ls sin omega t dt. So here we have taken the dt. The limits also we have taken to in terms of time. If you complete the integration both sides, we are getting the I naught equal to Vm by omega Ls cos alpha minus cos alpha plus mu. Now from this expression, if you find the cos alpha plus mu value, we are getting the cos alpha minus I naught omega Ls by Vm. Cos alpha equal to cos of alpha plus mu plus I naught into omega Ls by Vm. Now first you have to substitute the equation 5 in equation 0. This equation we have taken as a 0. So V naught equal to 2 Vm by pi cos alpha minus I naught into omega Ls by pi. The same manner, substitute the equation 6 in equation 0. We are getting the V naught equal to Vm by pi cos alpha plus mu minus I naught omega Ls by pi. This is nothing but a average voltage drop across the source inductor. For the average output voltage, now we have three expressions. One is V naught equal to Vm by pi cos alpha plus cos of alpha plus mu. This is one expression. We can use this expression if you know the value of firing angle as well as the overlap angle directly given in the numerical. This is second expression where firing angle is given, source inductance value is given, and value of load current also given. So by the time we have to use this formula to find the average output voltage. Sometimes the firing angle and mu is given and source inductance is also given. So by the time you have to use this formula to find the average output voltage of a converter with a source inductance. So finally, we can say very easily that because of the source inductance, the average output voltage will be decreases. Thank you very much for watching this video.